So let us study today the next type of alloy steel, that is stainless steel. So meaning of the word stainless, let me explain first. Stainless means it will not be corroded. In local language, you can say ganjarodak. So it will act as a complete stainless throughout the whatever life of the component. You'll never find these parts get corroded. So that's why these steels are called as stainless steels. So it is written clearly, these steels are having good corrosion and oxidation resistance, and hence the name stainless steels. So meaning of the word stain is oxides, or in Marathi you can call it as ganja. Stainless steel, ganja virahit steel. Steel in Marathi it is called as polar. Okay. So number of earlier types we have covered. This is the last type, which is main. There are different types also, and I am going to explain one by one all the types with its properties, composition, and application. Now remember, we have studied the effect of alloying elements on the steel. Number of alloying elements I have explained you. So it includes almost maximum elements I have covered. Out of that element, in front of every element, its properties were written and where it is used. So that on that basis, you might be remembering what properties of chromium we have written. So if you recall the memories of previous class, you find chromium is the important element which cause for improving the oxidation and corrosion resistance. So that's why I have written here, chromium is main alloying element. So there are number of alloying elements, out of which always some element is main. It is also called as major alloying element. No doubt carbon is present. Without carbon, it will not become steel. But apart from it, one of the element will play the key role. And that element here, which is playing the key role, is chromium. So that's why we can say chromium is the main alloying element. And what is the next requirement? It doesn't mean that you have chromium and then your steel will become corrosion resistant and stainless. Some requirements are there. So you must fulfill that requirements. What is the main statement regarding that requirement? For having good stainless properties, the minimum chromium in the solid solution should be greater than 13%. Please concentrate on this statement. I have explained you the effect of alloying elements on steel. How the alloying elements are behaving during their working in the any particular alloy. So one element or one property was studied, that is solid solution strengthener. So some of the alloying elements will get dissolved into the solid solution, that is alpha ferrite in this case, and it increases the strength of the alloy. Now, for having better corrosion resistance properties, for having good stainless properties, your chromium in the solid solution should be greater than 13%. Means definitely it should be in more amount, because chromium will be distributed in two places. The next statement is written, most of the chromium forms carbide. So most of the chromium forms carbide means its affinity for formation of carbide is more. Every element will act in different role. If you check the previous contents, what are the different roles? I will repeat once again for your understanding. The first thing, chromium, not chromium, any of the element, they are solid solution statement, they are carbide formers, they are austenite stabilizers, they are ferrite stabilizers. So each element performs different roles. So in this case, chromium is getting dissolved into solid solution also. Chromium is forming the carbides also. But most of the times, chromium forms the carbide. Then how can we see how much quantity of chromium has formed the carbides and how much quantity is added in the solid solution, that is ferrite. So for that purpose there is one defined formula. Let us see that formula. Write down in the notebook: total chromium is equal to chromium in the solid solution plus chromium in the carbides. So whatever x quantity of chromium you are adding, it gets distributed here. Now total chromium equal to chromium in solid solution plus 17 times percentage of carbon. So there is a logic for formation of carbide. So how much amount of chromium forms the carbide? So it is 17 times the percentage of carbon. Now on that basis you can see chromium in solid solution is equal to total chromium minus 17 times percentage of carbon. Now take one example. Suppose there is 0.5% carbon. Let us see this example. And you have added 20% chromium. So out of that 20% chromium, how much chromium will form the carbide? So 17 times percentage of carbon. So make 17 into 0.5. How much quantity? 17 into 0.5 is equal to 8.5. So out of that 20% chromium, 8.5% chromium will form the carbides. Are you getting the logic? So depending upon it, we can check if out of this quantity of chromium which we have added, this much chromium has made a participation or contribution as a solid solution strengthener, and this much chromium has a made contribution as a carbide former. For having good stainless properties, maximum chromium should be in solid solution, and that maximum amount is also given. See the previous slide, that is 13%. It is given here. So the minimum chromium in the solid solution should be greater than 13%. Then it will have good stainless properties. So if instead of 13%, there will be 8% or 10% chromium in solid solution, it will give stainless properties, no problem. But good qualities will be achieved after percentage crossing the 13. So let us see one by one accordingly. See this last statement. In addition to corrosion resistance, stainless steel is having good ductility, good permeability, and good mechanical properties. Apart from corrosion resistance, chromium also improves this property. Along with chromium, there are certain elements like nickel, manganese, etc. They will also help for improving the properties. But the major element is chromium. Let us go to next slide. Types of stainless steel. Now, if you read it carefully, martensitic stainless steel, ferritic stainless steel, and austenitic stainless steel. Based on what phase is present in the steel at room temperature, these nomenclatures are given. So definitely, martensitic stainless steel have martensite at room temperature. Ferritic stainless steel have ferrite at room temperature, and austenitic stainless steel have austenite structure at room temperature. Now, out of these three, which phase is harder? I will ask you anybody now. Omkar Mashalkar.
Yes, sir.
Omkar, can you
Yes,
please
sir.
answer this question? Out of three phases, that is martensite, ferrite, and austenite, which phase is harder?
Martinet, sir.
Martensite.
Yes, sir.
Okay, correct answer. So ferrite and austenite are soft. Martensite is hard. Okay. Now, definitely, whatever stainless steels you are observing in day-to-day life, just close the eyes and for time being and recall where these stainless steels I have seen, starting from your home up to your labs, everywhere in day-to-day life. Wherever you have seen the stainless steel, you will categorize it into these three types. So martensite stainless steel is the stainless steel definitely because of martensite. It must be harder. So where is the stainless steel which is used as a tool? Recall. So in that way, we will see martensite, ferritic, austenite. Let us see one by one. Martensite stainless steel. So martensite stainless steel is also called as Group A type stainless steel. Read it. Amount of chromium in solid solution is less than 13. So our condition having good stainless properties, it must be more than 13. But it is having little less chromium in solid solution. It is hardened by martensitic transformation. Hence the name is martensitic stainless steel. So martensitic transformation, how to obtain? Can anybody tell? In last lecture I have explained how to obtain martensite. I have explained it in water hardened steels. Who will explain now? How to obtain martensite and how to obtain perlite. Dhanashri. Dhanashri Sonona. Hello. Are you there? Dhanashri. If you are not able to listen me, please. Yes. Now you can talk now. Dhanashri.
Yes, sir.
So my question is how to obtain martensite. In last lecture only I have explained. Martensite is one hard phase which is obtained after cooling of steel. Can anybody tell willingly?
Yes, sir.
Yeah. Tell rhythm.
Austenite is when fastly cooled in water, then it forms martensite. And when austenite is cooled in air, it forms perlite.
Very good. Can you repeat once again?
Yes, sir.
Uh,
Austenite, when fastly cooled in water, it forms martensite. And
hmm.
when austenite is cooled in air, then it forms perlite.
It is cooled, not cold. Okay.
Okay.
So I will repeat whatever Mr. Rhythm has said. If you have perlite structure at room temperature, you have choices to convert it into any structure. For that purpose, you have to follow heating and cooling cycle. So let us take example. I have perlite at room temperature. I have taken one piece of steel in which there is a perlite plus ferrite. I want to change that structure. So first understand what is meaning of ferrite plus perlite. The crystal structure only. Ferrite means BCC structure and perlite means mixture of BCC plus orthorhombic because P that gives alpha plus Fe3C. Perlite is mixture of ferrite and cementite. So you have alpha plus P in microstructure means you have pure BCC that is alpha plus mixture of BCC plus orthorhombic that is perlite. So this BCC pure and BCC plus orthorhombic mixture that is called as alpha plus P. I want to convert into martensite. Means I want to change it into another crystal structure. And that another crystal structure is body centered tetragonal. That is BCT. Write down somewhere. So martensite is BCT. That is body centered tetragonal. So BCC body centered cubic plus body centered cubic and orthorhombic mixture heated at higher temperature it becomes austenite. Means what it becomes? It becomes FCC. And then that austenite is, if you cool slowly, once again same structure you will obtain. That is BCC plus and mixture of BCC and orthorhombic. But if you cool it fast, that is water quenching or oil quenching, immediate cooling will not give time for formation of BCC and the mixture of BCC plus orthorhombic. Instead of that, that FCC is converted into BCT, that is body centered tetragonal, and that is called as martensite, which is very harder. So this steel is nothing but martensitic stainless steel, in which martensite transformation is made by hardening process, and hence the name is martensitic stainless steel, categorized under group A. It have 12 to 18% chromium, 0.15 to 1.2% carbon. Now it is magnetic, hard, wear resistant. See the applications: razor blades, whatever blade you are using for shaving, that is martensitic stainless steel. Surgical instruments, the scissors, then foreheads, then whatever may be the tools doctor are using for cutting the skins and other parts, all instruments are made up of martensitic stainless steel. डॉक्टरांच्या कात्र्या, चाकू, काय असेल ते, that all contents are, or all instruments are made up of martensitic stainless steel. Then ball bearings, these are also made up of steels, which is martensitic stainless steel, because bearing should be harder, otherwise it will cause wear and tear. And your different cutting tools, if as per the requirement in the milling cutters and others. So this steel is called as martensitic stainless steel. Remember. Okay. Now let us go to next. Whether screen is visible? Hello?
Yes, sir.
Hello?
Yes, sir. Screen is visible, sir.
1 minute, just I'm trying to go to next slide. Some connection problem I'm observing. Just wait. Just wait for 2 minutes. Huh? Whether screen is visible? Rhythm?
Yes, sir.
Okay.
Yes, sir.
So next is ferritic stainless steel. It is categorized as a group B. If you read it carefully, amount of chromium in solid solution is more than 13%. So whatever chromium you add, out of that, the chromium in the solid solution, it is ensured that it is more than 13%. So read the next sentence carefully. As chromium is ferrite stabilizer, it can't be hardened by martensitic transformation due to absence of austenite. Very important and bold statement, because your concept is clear through this statement. I am going to repeat it once again. As chromium is ferrite stabilizer, it can't be hardened by martensitic transformation. Now, once again, go back to previous discussion. Martensite is always formed from austenite only. Remember, austenite is parent phase, which is above 727. So, whatever room structure, ferrite and pearlite you have, if you want to convert it into martensite, you have to go to austenite structure. And austenite only can be converted into martensite. If austenite is not there, you can't form martensite. What happens in this case? Chromium is ferrite stabilizer. I have explained you ferrite stabilizer properties. So ferrite, alpha ferrite is present at room temperature. But if some ferrite stabilizer elements are added in more amount, they will cause to raise that A3 temperature. So I will show that demo once again. Just turn pages back the your iron anchor diagram, and if you see that diagram, you will find there is a A3 line, and this A3 line is raised. I will draw here. Just wait. If this A3 line is raised, your ferrite remains ferrite for long time, maybe up to higher temperature. Just I am editing the pen. By the time you open your notebook, so I was saying A3 temperature is raised. So if A3 temperature is raised, in that case, alpha remains for long level up to higher temperature, and without formation of austenite, there is melting. So if austenite is not formed, you can't produce the martensite. That's why the ferritic stainless steels are having ferrite even at higher temperature and lower temperature. That's why these stainless steels are called as ferritic stainless steels. Now, how the strength is developed? Previous steel was very hard because of martensite. This steel is not that much hard as like martensite, but some strength is required. This strength is developed by solid solution strengthening. When chromium is get dissolved into solid solution, automatically strength of the steel increases. So here, chromium in the solid solution is more than 13%. Okay. Now see the total percentage of chromium, 13 to 27%, and comma, here is a comma, 0.2% carbon. So now this steel have less carbon as compared to martensitic stainless steel. And if you see the applications, this is the these base applications you are finding in your day-to-day life, your pots, pans, maybe domestic application, kitchen madli bandi. I hope you are getting my point. Vessels in the chemical and domestic appliances. So they have sufficient strength due to the solid solution strengtheners, that is chromium will act as a solid solution strengthener. But if you consider hardness is little less than martensitic steels. Okay. And this steel is partly magnetic and corrosion resistance is higher than martensitic steel. If you check the corrosion resistance of previous case, it is less and it have higher corrosion resistance than martensitic stainless steel. Now, let me give one example. If you go to market and purchase these pans, pots, then that shopkeeper, you can ask your parents. So he is showing the magnet in the hand and trying to explain us. See, it is not showing magnetic properties, it is good quality. So he don't know the theory behind it. By thumb rule, he can say that it is non-magnetic means good quality. But there is a logic that when percentage of chromium is more, these magnetic properties are reduced. So when percentage of chromium is more, stainless properties are more. When stainless properties are more, your steel have good quality. He indirectly he's saying non-magnetic means good properties. So this relation I explained you just now. So almost negligible magnetic properties are there. If you go to again further type, that is group C, which have greatest corrosion resistance properties. So out of these three, type C, that is authentic stainless steel, have greatest or highest corrosion resistance in all these three categories. Total amount of chromium is 24% and more, with 0.25% carbon, and this segregation is 17 to 19% chromium, 5% nickel, and 8.5% manganese. It is also soft, ductile, and it is complete non-magnetic. There is no question of magnetism for authentic stainless steel. Excellent corrosion resistance properties. Further, they are improved by nickel and manganese. Where these steels are used, engine manifolds, where we don't want to take any risk for corrosions. Wristwatches, sanitary fittings. If you check your good quality wristwatch, which is metallic, nowadays plastic watches are there. If you see metallic wristwatch and at the back side, if you see stainless steel and inner parts also, that is made by this authentic stainless steel. So if you read it, is it even if you read on the razor blade, if you are not seen earlier, now just when I explained, take any razor blade, topaz and other 7 o'clock, whatever may be, just check. It is written stainless steel there. That is also stainless steel. On wristwatch also stainless steel is done, but both are different. Both are having corrosion resistance, but wristwatches stainless steel have better corrosion resistance than razor blade corrosion stainless steel. But hardness of that steel is more. That's why it is used for making the tools. Next one is sanitary fittings. So sanitary fittings nowadays they are made up of brass and bronzes with steel coatings. But many times they are made up of pure stainless steel also. Pure stainless steel is costlier, and I'll help you how to identify whether it is made up of steel. From outside it is looking at the steel. You check your any of the taps, bathroom मधली आणि बेसिनची जे तोटी वगैरे असते, that is called as sanitary fittings and other tools, showers, etc. So if you see the old tap, you will find yellowish color. Means whatever the steel coating is there, this get removed and you will find the base, that brass or bronze. So that outside coating is steel coating, but I am not talking about that outside coating. Many times totally the tap may be made up of stainless steel. That will be definitely costlier. That's why people are making from brass and they are giving coating of steel. So these are the three types of stainless steel: martensitic stainless steel, ferritic stainless steel, and austenitic stainless steel. Austenite is present in that steel because chromium is in higher nickel. Nickel is this austenite stabilizer, and this nickel cause this FCC structure to remain there, and that's why you can't increase the hardness, etc. Only because of solid solution strengthening, the hardening happens or hardening takes place. And the corrosion resistance is excellent. That's why according to the requirement, the steels are selected. So group A, group B, group C, you just remember in the bracket only. Some of the books have given group A steel, group B steel, and group C. But you have to remember the names: martensitic steel, ferritic steel, and austenitic stainless steel. Now we are going to, so before I explain this next bit, let me show you previous three slides once again. See once again, you can take screenshots. And one more thing, whatever material available on these drives, I have updated with all the links. You can access it, but actually you should use college email ID, then there is no problem. But many students are not making login in their drives by college email. Even though I have made free access, you can check it. 2 chapters notes also I uploaded, good quality notes. So chapter 1 and chapter 2, actually old as per syllabus 1, 2 here there. Now one university will upload the syllabus. As per the modifications, these two chapters were made single, but now I came to know कि once again this one and two. If this in next lecture our two chapters will be over accordingly. So chapter 1 and chapter 2, as per this earlier pattern, I put these scanned copies, and you can use it for writing the answers. Day after tomorrow, I am going to take one test. That questions will be displayed during the class only. So nobody should miss the class. Tomorrow that cast time will be completed, and then next to that lecture, will complete that test. And you can have this, for one lecture there was problem in the recording, that's why I put the PPT, but other all lectures are uploaded. Those who were having the problem for range etc., they can download that all previous 9-10 lectures and study it. Okay, apart from it you can use class notes point to point with assignment questions, everything I have dictated it, and that is scanned and put there. So once again these slides you see, multi-incident stainless steel, ferritic stainless steel, you can take screenshot. This is authentic stainless steel. Let us go to very important bit, that is standards and specifications. I can write down in your book. So whatever types of skills we have studied by the time, whatever lectures we have covered, there were names. So pre-cutting steel, head kit steel, then tool steel, water hardened steel, oil hardened steel, inward steel, then alloys for heating element, Canthal, then stainless steel, Martin stainless steel, dual phase steel, Marazing steel. Whatever types of steels I have explained, in market if you go, and if you ask somebody to give me Martin stainless steel, nobody will understand. All these are theoretical concepts. In the market, all the types of steels are having some codings. These codings are as per standards. So you have to ask it 314 steel or 210 steel. So these code words are used for any of the compositions, properties and applications. And accordingly, you can purchase, or any market name will be as per the different standard. One slide is in front of you which I have displayed. So before we go to understand how to decode that codings, I will explain you what are different types of standards. Start, I hope you are writing it. Now there may be a short note, explain the different standards and specifications of the steel with example. This writing the three marks question is not so important in this case. Then what is important? The important thing is remembering this concept throughout the life. See, even you join any of the company as an engineer, there also you will find these standards are used, and it is very, very difficult to remember all the compositions. That's why you have design data book, steel handling book. So accordingly, you can check the composition there. So only code is given, and according to that code, if you want to see the what is exactly composition, you can open that book and check the composition. Now every standard have given different codings. Now, if you see last one, that is 9th, International Organization for Standards, that is ISO. So my voice is breaking. Am I audible clearly?
Yes, sir.
Yes.
Somebody has written the voice is breaking. So there may be problem with his mobile. Please check. International Organizations for Standard is ISO. You have seen ISO 9001, ISO 2015. This ISO is a one international body which decides some standards. Now, as per this ISO internationally, this code will be same at every country. Every country has its own standard also. Let us start with first IS. IS long form is Indian Standard. It is earlier called as BIS, Bureau of Indian Standards. And nowadays, we are calling it as a ISI mark, Indian Standard Institute. So all these three are one and same. IS stands for Indian Standard, ISI stands for Indian Standard Institute, and BIS is Bureau of Indian Standard. So example I will give. If you see next standard, that is AISI. Long form is American Iron and Steel Institute. See, this may be interview question. Any of the interviewer during interviews of core company, it may be asked to you. So I think 4-5 years back, our 3 students got selected in Jindal Steel. So it is one of the big core company. Their package was at that time, 5 years back, it was 6 lakh rupees. So such companies are taking interview on this basis. So they may ask you 2-3 codes and you have to decode it. It is not very difficult. Just by learning you can understand. So better way, you have to understand what different countries are using, different standards. Nobody is going to ask you what is long form of this in exam. But definitely it may be asked in the interview. Are you knowing SAE? How question will be? Are you knowing SAE? So your answer should be yes. SAE is Society of Automotive Engineers. For your kind information, you are in third year now. We are running some student chapters in the department. MESA is departmental level or college level. But standard student chapters are there, which is IEI. This IEI and the second is SAE. Okay. Engineering Association, Indian Engineering Institute. Okay. And this SAE is Society of Automotive Engineers. So that Institute of Engineers India and this Society of Automotive Engineers. I repeat once again, Institute of Engineers India and Society of Automotive Engineers. We have student chapters. You write somewhere so that you must be the member of this SAE. Our sale is there along with MESA and other things. So SAE has different chapters, different automobile oils, automobile parts. These are designed and coded by SAE. The next one is British Standard, BS. Next one is ASTM, American Society for Testing of Materials. Standards are not always for only material. Standards are always for materials, processes, parts, etc. So, American Society of Testing of Materials. That is a testing standards. So you can say, this test I have carried out according to ASTM 20. So some number may be given. ASTM 20 means some guidelines are given. For example, you are carrying out tensile test. So for carrying out tensile test, some ASTM 60, some guidelines may be there. So follow that guidelines and accordingly you have carried out. So that your test is correct and your values are correct. Nobody can take doubt on your values which you have tested by giving the reference of these standards. Now, next 3 are is JIS, DIN and GOST. Actually, these are their local language long forms. So JIS is Japanese standard, DIN is German standard, and GOST is Russian standard. You might be knowing only India is following British people by referring the English as a standard language. But Japan, Germany, China, Russia, and other countries which are developed countries, they are using their own language. Their kids are studying in their own language. So they are keeping English as a second, but their language as a first preference. So they have many developments. That's why they, whenever they are recruiting the people, they are insisting that people should learn Japanese, people should learn German, people should learn Russian language. For your kind information, we have many alumni in Germany currently. So there is a MS. MS means Master of Science. After BE or your BTech, whatever maybe, you can complete post graduation in foreign countries. Then that PG name is called as MS. Same PG if you cover or complete in India, that is MTech. MTech and MS is same. MS stands for Master of Science. So our people have learned German language, and it helped them a lot. Similarly, if you want to go to Japan, you must know little knowledge about Japanese language. Remember, Japan and Germany have great scope for mechanical engineers. Okay. Now, last one I have explained you ISO, International Organization for Standards. So this general, you have to remember the long forms. One more is missing here, which I told, Institute of Engineers India. You can write down IEI, Institute of Engineers India. Let us go to next slide. See, open your notebook. Now I want to give example. See, number of examples are explained. So, see how codings are decoded and how to identify whether this symbol is for process or whether this symbol is for contents and compositions. Am I audible? Am I audible?
Yes, sir. Yes, sir.
Okay. So in ISI standard, following notations are used. So let us see, somebody will say, I have used FE 325 steel. So I will not tell you why, I don't know what type, etc. Only it is given that FE 325 steel is used for. What is meaning of this? Meaning is steel with minimum tensile strength 325 Newton per millimeter square. Not understand what are the contents. For contents, different symbols are used. Usually C and T are the symbols used for plain carbon steel and alloy steels respectively. So if any of the steel have capital C word, you have to understand that is plain carbon steel. If any of the steel have capital T word, you have to identify it as a tool steel. Now, along with this C and T symbol, sometimes S, P, PB, they are also used. And if they are used, it will be free cutting steel. There are a number of guidelines. I have taken only few guidelines for your understanding. More than 1,000 pages are there in that book where these codings are given. Let us see the example 30C8. So I have made this component using 30C8. Suppose I have prepared one channel and I write in the bill of material. Name of material is 30C8. Means what I have given? C word is there, means it is plain carbon steel. And whatever word, whatever figure given before C, that is 100 times more than actual percentage of carbon. Okay, so divide 30 by 100. If you divide 30 by 100, it becomes 0.3. So meaning of 30 is 0.3% carbon. And now the word 8 is used in front of word C. As per their guidelines, by default, this 8% is for manganese divided by 10. I repeat once again, the word which is before C, you have to divide it by 100, and word which is after C, you have to divide it by 10. You are not going to write this theory in examination. It is only for your understanding how to decode. That I am explaining. So don't take tension ki how can I remember. So logic I am telling. So I will explain this. 30C8 means plain carbon steel with 0.3% carbon and 0.8% manganese. Same steel at international level have different code. They are using C30. So meaning of C30 is 0.3% carbon, plain carbon steel. Now you will say, sir, here C30 is before C, here 30 is after C. Yes, internationally they are writing after, and Indian level we are writing before. No issues. Everybody have different codings. Now I am saying that C30 means 0.3% carbon and 0.8% manganese. You will ask me in ISO symbol, where is the 8 is not written there, and how can you say that there is a 0.8% manganese? It is given in that book. Okay, so every coding you can't remember what are the contents. So just simply what is major element understanding is important. Next type, 90T Mn60Cr1. It is a T. T means to steel. So what is percentage of carbon? 90 is written before T. So it is as per Indian standard I am telling. 0.9% carbon. See, tool steel must be high carbon steel. That's why it must have more percentage of carbon. Along with 0.9% carbon, it has Mn60 underline. Now usually I told Yaman we are taking 10 times more figure. So if you take 10 times more figure here, so that is divided by 10. 60 divided by 10 becomes 6. But this still don't have 6% manganese. It has only 0.6% manganese. So how to differentiate? So as per guidelines, if you give underline to any of the figure, it is 100 times of actual. So 0.6 100 times becomes 60. That's why underline is given. And Cr1 means chromium 1%. So in this way, same steel, if instead of word T, there will be S, that will be pre-cutting steel. Okay. This is as per Indian standard. If you go to next type of standard, AISI. So remember, AISI and SAE have same standard. In bracket, you can write SAE. Write down in bracket. AISI standard and SAE standard. This AISI and SAE standards are using 4-digit figure. 2456, 2145, 1064, then 2259, whatever be the numbers they are using. What is logic for these numbers? So last, I will start with the end. Last 2 digits are 100 times percentage of carbon. I repeat, last 2 digits are 100 times percentage of carbon. Means, for example, in this case, 45. These are last 2 digits. 64. These are last 2 digits. So 45 divided by 100, that is 0.45. 0.45% carbon. Here 0.64% carbon in second case. What about these first two? First is type of steel and second is percentage of allying element. So 2145, actually there is a list is given in the book. So 1 means plain carbon steel, 2 means nickel steel, 3 means molybdenum steel, 4 means vanadium steel, etc. etc. 5 means chromium, 6 means chromium vanadium. So first digit means what type of steel, that is explained. So I know that I have taken example that if first digit is 2, it is nickel steel. And now second digit is 1 means percentage of nickel is 1. Understood? Second digit explains presence of major or percentage of major alloying element. Now you take the second example, 1 0. First digit means plain carbon steel. Means alloying elements are negligible. That's why second digit is 0. No major element except carbon. 0 means not 0%. So don't be under impression that carbon is 0%. Are you getting? One symbol means it is carbon steel, but no as such major alloying element. That's why 0 is used. So simply it is plain carbon steel with 0.64% carbon. Understood? Now third, BS standard. British are using their materials with the code as a EN. EN. Now what is the story behind it? You know that whatever inventions are made, all these inventions takes place during First World War and Second World War. Means 1914 and 1941 something. At that time, there was a requirement of weapons and whatever the tools, etc. Lot of developments were going on. So in that case, number of alloys were produced by the British people. So every time there is how to give name. Every time it is not possible. So by trial and error method, I have produced this alloy. I found that it is very much suitable for rifle. Suppose, example. So in that case, they have decided one code, that is EN. EN means emergency number. So EN1, EN2, EN3, EN4, EN5. In this way, they have given the number, and in front of it, percentage of carbon is given. Okay, it's like serial number. So you are using this EN8 in workshop. That's why I've taken example. EN8 contents are 0.4% carbon, 0.65% manganese, and 0.06% sulfur and phosphorus. Sulfur and phosphorus are always less in content. Okay. So in this way, you can decode. If short note is asked, you have to write what are the different standards and take 1 or 2 examples. This question will be asked for 3 marks in theory. At the same time, this question may be part of oral examination, and 100% it will be part of your interview. If you are going to appear for any of the core company, these codes will be used as a questions by the interviewer. So today's class we have studied types of stainless steel, martensitic stainless steel, ferritic stainless steel, and austenitic stainless steel. And at the end, we have covered standards and specifications. Okay. Thank you. Okay, and you please study whatever notes I have given on the drive. You can download it and start studying. In tomorrow's class, we are going to start the chapter or same content, part B, that is cast iron. So here steels are covered. Remaining end part of the chapter is cast irons. Thank you very much. You can join next class.